Okay, everybody, good morning, and thank you for coming along to this week's OCP HPC subproject meeting. So today, what I'd like to do is we'll go through quick introductions for the new person on the call, Mick Felton, in a moment, and then I'll give you a little bit of an update on the OCP Global Summit preparation. I'll show you some 3D models that we've got printed out. Then the main tenet of this meeting really is I want to get into the swing of transitioning from the concept we've been working on for so long to a reality of the HPCM module. And with Greg is on the line, so it looks like we're going to start getting underway with some of Greg's help. And so I've started to put together some top-level planning, and hopefully there are several sort of discrete projects I think we could split into separate work groups and work on sort of independently and cross-collaborate as necessary. So I'm going to just share with you the breakdown as I see it right now, and we can debate those various topics, and if I'm missing anything. And then we can start to get underway and maybe get some individual leaders for the different work groups as skill sets are appropriate and can help out in those different sections. So that's the plan for today. So to kick off, Mick, as it's your first time, would you mind just giving a brief introduction as to who you are and who you're with and your interest in attending?
Yeah, hi everybody. I'm Mick Felton from ASUS, and we make cables and connectors. I'm the director of engineering here. Just the interest is basically just to try to see, what, if anything, is happening in the group. That's by way of cables and connectors. Definitely, I have a broader interest. I've worked at Dell for 30 years, so I know a little bit about computers and storage, and also the shared interest there too. So, just basically just taking a look and see what's going on.
Okay, Mick, thank you. Your timing is good, and we do need a lot of help from the connector people. So you might have taken 2 steps forward there.
I see you've had a little bit of experience yourself from going to your website there. So.
Yes. I was with Molex, so I know those guys quite well, and I've worked with Samtech in the past, and yeah. So, but yeah, the interconnect we're using pretty standard interconnects, but we do need some tweaks going forward. So that's where we're going to need the help from the industry. But okay. All right, thank you, Mick. Welcome to the group, and as ever, everyone's welcome. So no problem. So just on the next topic, OCP Global Summit update. So I'm not sure if I actually could confirm last time, but the great news is we have the Composable Memory Systems OCP sub project has kindly given us a little table on their experience center at the OCP conference. So we've got a 2x2 tabletop, and I'm going to be showing some 3D models. So let me just stop sharing my screen a minute, and I'll put my camera on so you can see me on this camera. Yeah, so these are some initial printouts I've done. By the way, I'm going to the Bristol Tech Festival here in the UK next week, so I'm going to be showing these models off at that Tech Festival. And Greg's going to join me on the panel session there. So this is the module. In its reality, you can get a better feel for size. I've got big hands, but it's quite a sizable module, and it's fully assembled in this case, and we can see we've got the E3 drives in place, and they are all, it's not printed as one brick, so these are removable. So we can get if you want, I can send you one, Michael, and you can get some Samsung logos stuck on there, or send me some stickers.
That would be great.
So that's that. So this, you can see the power. These are the power pins. There are additional mounting bolts that are here as well that would protect those pins. And you can also see the just making sure my camera's here. These are the water inlet and outlet areas as well. And then I've got a separate model which is broken down into the pieces. So here we've got the PCB. So what we're gonna get this we're gonna get another model is being made as we speak, and we're gonna be painting that as well to get sort of make it jump out a bit more like the PCB and the components, etc. So this has got the big chip in the middle with some chiplets on it. It's just a mock-up, and the power bricks that we're choosing to use. It looks like the industry is now. I don't know if OCP was involved in this or just the hyperscalers themselves, but there seems to be a nice power supply format. Each one of these little bricks is 130 amps capability. And then they've got these also these 48 volts to 12 volt converters as well. Seems to be industry standard footprint. So MPS make these in Renesas. And I think there's one other, I can't remember the name of. So therefore we've got multi-source on the power components to drive these power hungry chips. And then on the back, we can see our interconnect. And so, you know, actually for Mick, our new chap, you can see that the connectors are directly underneath the processor chip. So the big problem with the connectors is they invariably have mechanical strength pins that go through the board. So we need versions with no mechanical strength, all surface mount mating. And we would get the mechanical strength, and this is where we need some more mechanical expertise from the actual cooling frame that goes around this. That will make sure the modules go in very perpendilarly, so they can't be sort of torn off by a ham-fisted person inserting them incorrectly. So those are the tweaks that we need. These are standard TE, or no, originally the TA1002 connectors, EDSFF, and these ones on the edge here are currently MCIO, the PCI. New PCI connector, but they equally could be some alternative Ethernet connectors as well. So that's the PCB, and then as I just showed there, this is going to be the expensive piece, and we need to find out how to manufacture this. This is going to have water channels through it, so the water comes in here and flows through these channels to conductively cool the E3 modules, and that then mounts, if I can get it the right way around. Onto the PCB mounts onto that, and then the water gets flowed from that one frame which cools the drives up into the top lid, and this is literally a complete open space here. So we literally immersion cool the 1 kilowatt processor, but in a very small pool of immersion liquid here. And so all of the components will be exposed to the liquid. To do that, we're working. The University of Illinois is involved, and we're working with them in terms of some conformally coated copper on the components to isolate with a conformally coated insulation as well, to actually be able to use water, but we will experiment with using some inert fluids as well without any coating to begin with. So that's what we're going to be showing off at the summit, as well as the presentation that we gave a little rehearsal. So I've been refining that, but largely that's the same. So that's the update on the global summit. So hopefully that should be a nice awareness thing for everybody of what we're up to. And maybe we can recruit some more interested parties. Okay, any questions on the summit? The only other thing I would say on the summit is it's just going to be me there. So I'm not going to be able to man the booth 100% of the time. So if anybody's going to be there, if I can get any volunteers, let me know. I think maybe another guy I'm collaborating with on using these modules he may be able to help me out. But if I've got a couple of names where we can maybe time slice a little to show what we're up to, that would be appreciated. So please let me know if you're going to be there and if you can help out from time to time. Okay. So on to topic 3, transitioning the HPCM from concept to reality. So what I'm looking to now is really, and I've been working with Greg on some of this in terms of we need to get the top level planning going. We've touched on this before in the past, but we've really never got off the ground. But really the timeline to the various critical go, no go risk reduction gates. So I've not actually put the timeline together at the moment. I've just done a sort of a mind map of all of the tasks that we've got to do. And Greg has kindly given us a stretch goal that we'd like to get to have a 2-year plan to get a wall of compute machine with several different HPCM modules up and running. So that's a nice stretch goal. I think, Greg, you call it your super up and running in 2 years.
It is indeed, yes. We are looking for a AI training super. So that's the idea, is what's going to get put to work for.
So that's the stretch goal he's given us. That's what we're getting prepared for. So let me switch screens. So
under my mantra, buying no more pizza boxes. Fed up of buying very expensive 1970s design paradigm pizza boxes.
Right. Yes. No more of those. I've realized I've stopped sharing my screen. So there we go. Let me go back to sharing the screen. Okay, can you see this mind map? Yeah.
Yes.
Okay, great.
Yes.
So basically what I've called this is like breakout work groups. So I don't know if we necessarily need a work group for each one of these, but I was thinking that maybe if we can get some work done between our 2-week meetings, then these are the pieces that I've broken it out to. And some have more urgency on getting going than others, as I'll touch on. I'll just go clockwise from the top here. I've got some miscellaneous mechanical ones that I didn't particularly fit into other areas, but just in that area, we've got what I've called thermal containment here. Is we really want to capture all of the heat energy into the water and extract it. We'd rather the heat energy doesn't emit into the data center itself, or a minimum amount, so you don't need a massive amount of data center cooling. The heat of the water being ejected from the module is planned to be 65 degrees C or higher for energy recovery purposes, and therefore, the data center itself would be running at around 65 C, and that there'll be no humans allowed in there. So that we may get to that point with a robotic approach in the future, but looking at some thermal containment to minimize the amount of leakage, and then you'd still need some level of air conditioning in the data center itself to keep it. But we try to minimize the need for a secondary air conditioning in an ideal world. This is like the vision of where we want to get to. So that's that. There's the E3S modules. We need to get some latching mechanism into there, so they hold in place once they've been plugged. We haven't really got that in the model at the moment. And just the cable management of when we get these all cabled together. In an early version of the chassis about a year ago, Molex did a nice implementation of the topology cables to show that it's viable, but we just need to do that again with our latest setup. The next topic is power and cooling infrastructure, and I guess we've done a fair bit of work on this over the years as well, and more so recently, but with a lot of input from the various thermal people. So thank you to all of them over the time period. But essentially, with the University of Illinois willing to do some research with their conformally coated approach to cooling, we've got as you saw from the 3D model, we've got the basic architecture designed for the water flow. And so we've got that designed, but we need to design a module, a load module, which is just going to be a test vehicle. It's not going to have any real chip on it. But Roger Beeston from Load Slammer, Prog Analog, he is building a VP. This is a Xilinx FPGA, their big emulation chip they just released. He's going to be building a Load Slammer device, so it'll just have load CMOS transistors in there that can burn a kilowatt of power. And we will design the card to supply a kilowatt with the MPS power supplies, or whoever can supply that format that I just showed you. That's what I just said there. And the idea is that we will be able to get to test cycle the maximum thermal, maximum power delivery and the thermal cooling with this setup. And this is going to be like the critical piece of this, or this is a critical piece of proving that we've fundamentally got the power delivering cooling design good enough that we don't need to make any major radical changes to the module design, because that'll derail everything else. So this is a little bit of a critical path in my mind for us to get this done. Going to the next topic. By the way, please just jump in. I can stop on each one if you'd like to ask any questions. Okay. The next ones, I've split the BMC into two pieces, a software and a hardware. So this is the hardware piece. As we've discussed, and we had a presentation from Lattice, they're doing this Libra BMC is trying to open source the entire hardware of the BMC hardware. So this is all from a root of trust perspective. They want everything to be open, and you could implement. So they're using an FPGA approach. I think both Xilinx and Lattice have been involved in that, and we've had Lattice present. So the current planner record is for us to put the Lattice devices down, and we'll have that hardware infrastructure there. We need to work in the compatibility with DCSCM, and I do believe that there is a Libra BMC DCSCM implementation, so that will be good to look at. One of the things that I think Mitch is on the call, Mitch did bring up, and it has been on my mind for some time, is the control plane network architecture. How do we connect all these? Whilst we've got lots of sideband interconnect, they're sort of ancillary device management sideband in I think we need a proper control plane architecture in this. I've had some ideas on how to do this, but this is one piece of the hardware aspects of the BMC that we need to nail down. Any questions on that one? Okay. Then our first HPCM module. Current planner record is that we're going to do the VP 1902. We have all the information from AMD on this device, so I think we have everything armed to get a schematic and PCB team running with this. As I mentioned, we're using the same package, the load testing package from Load Slammer. So the actual design effort into building the power supplying and the Load Slammer test vehicle for the thermal and power will be the same base design from a power and processor perspective for our first module. So at least we'll be able to leverage the effort there, but we need to obviously fully complete the design of the module to make a real module. So that's the idea there. And the target application is that we would be going, using this as like an emulation platform. And this could go into a chiplet enablement strategy as well that we've been talking to ODSA about, where we bring simulation and emulation into the fore here. So that's that one. In terms of other HPCM modules, Greg does have a desire for an MVP suite of modules, and he is very interested in a number of Intel ones. I don't know if you want to elaborate on that at all, Greg, on modules.
The modules that suit our stack, and Also, as well, I just think Intel as well are quite a long way developed with CXL on their FPGA line. Therefore, it should give us an easy route to CXL 2.0 adoption. That's really the confluence of factors that make it make sense for us. It looks like Intel are going to be somewhere close with CXL2 for Emerald Rapids, and the HBM variant, so the Emerald Rapids Max, would offer us a form factor that would fit HPCM. And then if we combine that with the Agilex parts that also support CXL 2.0, then we actually may get somewhere close to being able to run CXL2 sooner rather than later.
Excellent. Yeah, that's that. I mean, that to your point, by the way, that the
and it gives an application fundamentally, which is what pays the bills. It's always useful.
And but the CXL one is a pretty good point that they're obviously making a dedicated chiplet that they've got. So I guess that's going to be a good reference one for CXL enablement testing purposes. Sorry guys, I'm getting lockups with my I've got a dual screen using my iPad and it's just playing up on me here at the minute. So I just want to I've just seen a few more people have joined us. So hi everybody. Hi Bijan.
Hi, unfortunately I have to leave.
All right.
So
And Callum. Hi Callum, thanks for joining. I think that's the two people that joined. I just wanted to see that.
Yeah.
Okay. This is giving me. There we go. I'm not sure if I'm blocking your screens. Are you seeing the Zoom images, or do you just see in my screen?
Just your Google Doc.
That's good. I'm the only one being blocked by. I can't move it around. So the middle of my screen is just completely blocked. Let me stop sharing and just restart a minute. This is a bit of a pain in the butt, to be honest. Or maybe it's operator error, but I don't want to do that for sure. There we go. Okay. Okay, so Bijan and Callum. I'll make a note of those two. So there's a couple of things in the chat. Oh, that's just Bijan. Okay.
Chat, why are you doing that? Michael, are you still there?
Michael Choi.
Yeah, hi Michael.
hi.
Are you you guys still okay to supply the E3 memory modules? Have we got a range of capacities available in those?
Oh, I'm sorry, I didn't get you exactly.
The E3 modules from your division, they are available today in a range of capacities and sizes.
Actually, that's what I'm working on right now. So I'm checking, status right now, and the availability. So we are in a big company. So I'm sitting at the memory solution lab. So I need to check with the product planning team and then sales marketing side in terms of the availability. So maybe next meeting I can give you some update on that.
That'd be great. I mean, that's one of the big rationales for us, because we just the flexibility and the spiraling cost of DRAM is in our systems is really what's kind of been driving us to go down this approach. Obviously, a close relationship on how we develop the memory tiering will be really important.
Okay, yeah, let me work on that, and then I will let you know, the status.
Great.
Actually, last time I spoke with Alan, and I asked Alan, you know, when we need this, you know, the part, and then maybe early like next year. So yeah, I thought, you know, that's our timeline, but I don't know, you know, your timeline is, you know, like a sooner the better, something like that, right? Okay, anyway, let me work on that, and then
Yeah, so I
will
think
let you
its
know.
timeline is going to be the same as ours anyway. So I mean, Greg, we're not going to have anything before the end of the year, are we? So
I doubt it. I doubt it'll be 24, but I would hope by the end of 24 we might be getting somewhere.
yeah,
Okay.
so yeah, I mean, earliest the first half of the year, but definitely not by the end of this year. So your timeline that we mentioned last time, Michael, is fine.
Okay, great. Thank you.
All right, so I've managed to get Sharon again. Okay, thank you for that little interlude. Okay, so hopefully everyone can see my screen again. Shout if you're not. So yeah, so we can kick off more HPCM modules as certain vendors get more interested in jumping on the bandwagon when they see we're making real traction now. Then we can sort of kick off modules in parallel. Hopefully, obviously, the first one's going to be a bit of a pipe cleaner. So, and then others can use that as a template for the various things like the sideband management, etc. So, you know, we may not want to get too far ahead of our skis until we've got some way down the road with the first module. Then I've got this little category that I put in as open interface definition. So this is going to be pretty critical. You know, we're going to need, because this is a fully open standard, we're going to need to make sure that all of the critical interfaces, and these are really hardware interfaces we're talking right now, of the electrical, mechanical, so the water, the connectors, etc. We're going to need to make sure that we have a multi-vendor solution, you know, or some sort of cross-licensing going on across those. And also the system management software needs to be completely open, because I think there's going to be a lot of innovation. I'd like to move on from the 1970s I2C a little bit, and there is some interesting progress there. But so all of those efforts, that's the software piece that would need to be very open, but we need to make sure we nail that so we don't get trapped in a corner that we've got an open standard that has a proprietary interconnect that stops us from being open. Rolling around into, as I mentioned earlier, interconnect optimization. So we need surface mount only connectors. We can't have any through hole aspects to those connectors, because we're literally back to back with the compute on the other side of the board. We need some mechanical latching in terms of when we plug cables in, how are we going to mechanically latch those? And also, we're designing, the architecture is designed for the potential to cool active cables. So if you've got an active cable which is burning maybe a couple of watts, we look to tap that into the water cooling piece. So that would need some tweaks to the connector casing to cool the active devices. And that should be good for both near packaged optics and any actively retimed cables as well, or redriven cables. Then we need the different cable options. So depending on how these modules are configured close to each other, we might want certain lengths in setups of cables so that you can build many different topologies quite easily. So we're going to need a range of part numbers with different cable lengths, etc. And then we do need to think about the cable management around the modules, etc. And that's I've got that up in the miscellaneous as well. I sort of copied it into both of those areas. So that's the interconnect. So this is where we need some connector companies to get in, you know, knee deep with us on helping us. I think that we can make progress by just taking off the shelf connectors and in pulling the through hole aspects off of those connectors. So in prototype world we can do it, but we need to quickly get to maybe some variants of the connectors from one of the suppliers that's prepared to do those tweaks for us to begin with.
Alan, I'm just going to put it out there. After we said the other week about potential cable jumble, on these boards, you get to complicated topologies.
Right.
We've been experimenting with printing very low resistance tracks on films, double-sided, basically helicopter tape films.
Yeah.
Is that potentially a way? Because you get a very low volume cable with
Well, so
with a very high signal integrity.
yeah, so
Very low loss anyway.
I'm not the best guy. So certainly Molex and the likes have that capability. They all have the sort of flat, flexi, rigid type approach to making cables. I'm not entirely convinced that they're better signal integrity than the twin-ax approach, because they look more like a classic PCB that is a lot worse signal integrity than.
Well, the ones I'm talking about, we're carrying 20,000 volts over them for virtually no loss, because they're graphene is the actual material that's moving the electrons.
Well,
it was just a thought. There might we want to consider film-based cabling.
Yeah, that's possible. Obviously, you end up with it being very flat and thin, so maybe it might be more challenging to bend in multiple directions. But yeah, so certainly
okay.
could look at those different avenues for sure.
Yeah.
So that's the interconnect optimization. Application focus. I got this one maybe a little bit confused. The application focus that I said we're going to stick to was ASIC emulation, but what I also decided to throw in here that may be a little bit confusing is I like the idea. It seems to be gaining popularity. There are so many changes going on in our industry right now at quite a macro level. That like CXL enablement, for instance, there's so many players bringing pieces to the market. This would be good for interoperability testing and prototyping and experimentation of building heterogeneous systems of this. The chiplet enablement we've discussed in the past, so that and the emulation approach, simulation to emulation, could help with the chiplet enablement world as well. So I've been working with OCP ODSA on these aspects, and more recently, I've been talking about how we would enable photonics, and we could provide a nice migration path from electrical cables to near package optic cables to co-packaged optic solutions potentially. One thing I found through attending a few conferences with these guys working on the silicon photonics is that they're desperate for being able to plug into a wider ecosystem once they've got their various technology pieces proven, or even in prototype form, can they partake in a bigger system. So I think photonics enablement is another nice area for us to dig into as well. So they're not really applications, they're enablement, but their enablement, it will be very useful for various applications, obviously. But ASIC emulation is our primary target area right now in terms of an application focus. Any questions on that one? Okay, then on the BMC, on the software side of BMC and fabric management software. So we've got OpenBMC, which seems to be, what everybody's doing these days. So there's no problems there. Redfish seems to be the chosen one at the higher level, and in fact, there's a lot of Redfish work going on in OCP, the composable memory systems for the CXL fabric management. And Greg also mentioned, rightly so, that the coordination. The key thing about the system management side of these modules is what I call a pre-runtime discovery. You want to discover the entire network. You want to, and a bit like the CXL composable memory system, you need to discover what's out there and what memory you have out there, where it resides, what the latency that is to it from various nodes, and you need to then build your memory map from what you've discovered. So I think we need much more system management sophistication going on at pre-runtime, and then you need to pass that intelligence up to the runtime at some point, so that the various runtime stacks, software stacks, can actually leverage the infrastructure. So there's a lot of work to be done here, and this already is a big time in the open community. And this is where I think we could get quite heavily involved in the software to a greater or lesser extent, in terms of our needs from that management stack. But at the application level, the runtime level, the software there, I see that is out of scope from us. So in this, we're like adjacent scope on this, and we might drive some unique needs because we are such a modular architecture. So that's that side. And then finally, which maybe should have been the first one, is the wall. The wall itself, we plug into the wall. And so that's going to provide power. So basically, we've got facility power, which comes in different guises, depending on different facilities, different free phase or where you are in the world. And we need to convert that to the 48 volts or 54 volt DC that we need for the modules. Any wall we design and build is, when you've got thousands of these modules, it's going to be a pretty hefty load. So we're going to make sure that this wall needs to be designed to be majorly load bearing. We need to have a 65C control loop, water control loop, built into the design of the wall, so that we can maintain an output temperature of 65C or hotter. We're looking at not two phase. We're looking at coupling into two loops. So we're going to have a separate water loop per column of HPCMs, and a heat exchanger to take it into the facility water and taken out from there. So that needs to be designed. So we've got a basic template of our starting point, but we need to work from there. And Kevin, I don't think, is on from Murata. He does the power supply, so he could help us out with the power conversion. So we need to work with him on this one as well. Just the fundamental design and construction of the wall itself in the data center. And we're going to start with a 4-module benchtop variant, so that, like a lab rat for researchers in universities, etc., and labs to play with these modules and wire them together as they wish for their different application experiments. So that's the tops. Is there anything that anyone thinks I've missed in terms of what we should be in scope of what we need to be doing here? Okay. So I split these into what I call breakout work groups. Like I say, maybe some of these could merge, maybe not. So what we're going to need to do is to get. I'm sort of going to be partaking in all of them the way I see it, and I'm going to be like the bridge between, make sure everything that's being done in every work group doesn't step on the toes of what's probably be done in the other work groups. So the overall
phrase you're looking for is standards architect.
The standards architect. Okay, thank you. But we're going to need some leads on all of these different areas.
Yeah, I like, here the right side bottom, open interface definition. This open interface that include this everything on the wall architecture, I can see something like that. And then defining this open interface for the HPCM, I think that's the very important, actually. Open standard interface to, for me, like, since we are dealing with the memory and storage, so there's no memory pool in the data center today, but with the CXL, we can create memory pool, and then using this standard open interface, all the like XPU or CPU, GPU, FPGA, or SoC, APU, NPU, whatever, can access this memory and using as a dynamically, attach, detach kind of capability, which is a composable memory way.
Yep.
Using this standard interface, we can achieve, something like that.
Yes.
Yeah.
That is the idea, for sure. And now when it gets into so again, just to re-stress, everyone that's been on this call knows this, is obviously we're trying to do this at the hardware level, the electrical and mechanical hardware, like the interconnect and the cables, so that we can make sure that everything can connect together. And ideally, the protocols we would all normalize in the future to maybe something like CXL as that matures. or CXL and Ethernet, you know, the way this goes. But we're not, you know, the key thing of this architecture is that you could build any machine you want if the modules existed. So like if NVIDIA had all their modules in HPCM format, we could build an NVLink system with their software stack, or we could build a regular server with a regular software stack that everybody uses today. Or so that's my goal in terms of the openness is we're not incompatible with some of these proprietary buses. The only thing that we need to make sure we're compatible with is if you plug an NVLink into a Infinity Fabric, the pre-configuration system management software knows that you've done that and doesn't let you turn the system on. Or if you both support PCIe on those links, for example, or CXL on those links, then you tell the processors to go into compatibility mode and not native mode. And so that's where I think. So, but fundamentally, I want this to be, you know, we'll be boiling the ocean if we try to, or I think we could be stillborn if we say this only works if it's CXL. I think we've got to be more nimble at supporting backwards compatibility with proprietary, or at least pieces of the network could be proprietary pieces in proprietary networks. Does that make sense?
I think that's a good strategy. I mean, hopefully CXL will become the open dominant standard, but there's a long way to go for that to happen.
Exactly.
Yeah, I totally agree with it. You know, your comment actually. It could accept any kind of, you know, available technology that it can create this memory pool in the data center, like NVLink, CXL switch, whatever. Yeah.
Okay, good. Okay, so this is where we're at. I know this is going to be a request of how many, you know, who's left standing when everyone else steps back. But we're going to need to start to pull some lead, you know, some volunteers that may want to be involved in leading this. You know, Greg and I are going to be tucking into making all of these things happen. So we, you know, we're going to need to find a way forward to get all these things kicked off sooner than later. But if people are interested in diving in with both feet and think that you can get your company's support, then you know, everyone has contributed and been here for the duration. It'd be great to get you guys involved, and Greg and I will be happy to talk with you on how we get these various pieces of work going and get onto a committed timeline that we can deliver to.
Hey, Alan. This is Darwesh. I'm curious how you think about the application side of things. Like, are you interested in getting sort of as many domain-specific use cases onto this platform, like early? And the reason I asked that is I can help bring my chiplets to the ecosystem as well as the companies in the Wei-Li ecosystem. But I'm curious, kind of, that's probably like the second half of the process, maybe.
Well, yes and no. I mean, to be honest with you, Darwish, that's a very good point. So, you know, I'm as you can tell, and as you know, I'm vision driven, right? So I'm knowing where we're trying to go. And but the only thing with vision driven as well is I've wound it all back to the practicality of this module. But there's a ton of work between the module and the vision as well, which, to your point, you're talking chiplets, right, for your stuff. So the chiplet enablement angle plays well there. And I've been talking to the Ventana guy. I've forgotten his name. The CEO of Ventana.
We know Ventana well. I'm sure we're talking the same guy, Travis or
Balaji.
Oh, Balaji. Yep.
Yeah. So I talked to Balaji recently in terms of, you know, what we're doing here, and so and the desires on the chiplet enablement side as well. So yeah, we need to get that ball rolling. So so I'd suggest you speak with Balaji, and I don't know where his plans are going, or whether he sees this as a good path forward or not. But yeah, that's and so that's certainly one aspect, is on building an HPCM module that is proving the chiplet enablement side of can this approach work, would be good. And I don't know, and I'm not sure what you're doing, Darwish, in terms of, you know, when you've got your chiplet and you want to play ball with 10 other chiplets, be they IO or processor or whatever. But to that point, you know, at some point you must simulate and or emulate your own chip, and one assumes that all the other chiplet vendors will simulate and emulate their chips. And so the idea there of us starting with an emulation platform is that somebody could emulate a complete SoC with like 2, 3, 4, 5 chiplets in it, and then actually drop real chiplets in when they come online and plug them into the rest of the emulation platform. You've got a real chiplet with the rest emulation, you know, depending on which chiplet comes first. And so building HPCM modules like that to sort of help to test the chiplets out in the emulation platform is one of the ideas that we were going down for the CXL enablement route. And I was working with Marek. Marek is doing the business document in OCP ODSA. And so that was a sort of a bootstrap approach that we were talking about there. So that might be a good one for you to plug into, Darwish, as well, on the OCP side, the ODSA side.
Yeah, I think that's interesting. Like the emulation problem is a huge problem. Like there's not a good solution right now for that, and it's really manual and painful. And we work with, I think, seven or 8 chiplet partners that we have to have interoperability with, and it's, as you can imagine, it's not fun, and it's really manual, and it's yeah.
Well,
so
see, that was it. I was thinking, you know, the history of emulation platforms. I mean, they're owned by the big guys now, Synopsys and Cadence. But if you think about it, these FPGAs, these are pretty damn big FPGAs. These latest ones from Xilinx AMD, and they have their own real chiplet interfaces, right? Which are challenging. But we could, you know, the emulation team or effort that goes behind a sort of an emulation chiplet emulation platform could actually define the bunch of wires emulation chip, emulation engine, the UCIe emulation engine. There's another startup, YourChip, which has got their own little emulation engine. And so people that then design their chiplets could actually plug them together in the emulation platform. So yeah, I can see that making a lot of sense as the chiplet community evolves.
Yeah, I'm definitely interested in the emulation part. We have VP 1802s in-house today.
Yeah.
And it's interesting. Yeah, it'll be interesting to see. So I'm definitely interested in the chiplet enablement as well as the like emulation aspect. And I can bring a bunch of companies that can like test drive this thing, and also probably supply some of the emulation C models and the RTL and things like that.
Okay, well, so that's great, because the VP 1902 is the first one we're doing anyway, which will be a bump up from your 1802. And if you or your family, like Balaji is the man to speak to, I think, are willing to say, actually, there's a strategy that we could put together here on this platform of simulation to emulation to chiplet in the loop. I call it a hardware in the loop. So you've got a real chiplet in the emulation platform itself, when you've got real chiplets exist, and but not everything exists. You know, if you guys could sort of build out a test strategy and a bring up strategy, that could be leveraged on an HPCM, and you could build HPCM sort of bring up modules that had a certain number of chiplets connected together, but then an FPGA emulation interface to bring in emulation where the other chiplets didn't exist yet. So that would be that's a sort of a vision that I've been painting with the ODSA group. I mean, that would be huge if we could get that side of it going. That would be a big boost to driving HPCM as a valid standard. So thank
Yeah,
you.
let me have some conversations there. I do have to drop in a second, but that sounds really interesting, Alan. I will have the conversation and maybe let's. Are you going to be? You're going to be at the OCP summit in San
Yes.
Jose.
Yes,
Okay. Okay. Then I'll sync up with you then on how those conversations went. I'll be there as well, so maybe we can talk about it there.
sounds good.
Very good. Thanks, man.
All
Thanks,
right.
Alan.
Well, on that note, we are at the top of the hour anyway. So, all right, everybody. Well, thanks very much, and I'll see you actually in 2 weeks' time. It's the OCP summit, so I'll probably cancel the next meeting in 2 weeks, guys. And if you come into the summit, then come and say hi, and if you can maybe help out an hour or two on the little demo stand, that would be appreciated as well. Just ping me a message that you're happy to help out.
As we get these work groups formed up, I'll get a bunch more of our folks involved to help flesh these out.
All right, sounds great, Greg.
So
Thank you. Thank you, Alan. I will see you at the OCP.
Yeah, look forward to it. Cheers, Michael. Cheers all.
Thank you. Yeah, thank you.
see you
Guys.
soon. Bye.